All right, Coach Jay here. Good to see you all today. I got my lucky hat on. Let me see if I got it. There we are. Bah humbug. Hey, hope you're having a fantastic day. This is our first FRQ podcast. I wanted to just kind of do it real quick to talk through a couple things, and that way, if you have any questions on it, we can discuss it, talk through it. So let's do this real quick. Let's go to our first FRQ. Let's go through this, and we'll go from there. So first thing is this problem we did in class, just a heads up. I wanted to at least put the, in fact, let me do this. I wanted to at least put the answers on here so that you could see it. This is kind of a big deal in terms of just making sure that you've got all the ins and outs to what's expected on this problem. So I wanted to at least throw this up here. So this problem, here's the answers. So basically, this one's not really fancy, just trying to give that to you from what we did there, okay, in class. We're going to do that tomorrow. Okay, so this problem right here was one that we did in class. We started it, and I wanted to continue it in terms of just kind of showing it, proving it, and going from there. Just remember that A is not a part of this question, and so just a heads up on that. Okay, so first off, the first thing I do is when I come to a problem like this is if I think that it's really difficult or tricky, I always like to do my state, plan, do, conclude, okay? And I'm going to give myself some space here, and then I'll conclude on this side, okay? All right, so let's talk about what this is telling me. Let's talk about the top. In a city library, the mean number of pages in a novel is 525, okay? All right, so first thing, in a city library, the mean number of pages in a novel. So we're talking about in a city library. So my big N would be novels in a library, which would be quite a few, I think. We're going to assume this is a pretty big library. It's 525. So that 525 refers to my parameter. Notice it's not a proportion. So we're going to say that mu is 525, okay? All right, so there we are. It says with a standard deviation of 200. So my standard deviation would be 200 pages. But then it says this, approximately 30% of the novels have fewer than 400 pages. So if we talk about that 30% of the novels, of all these novels, we're going to talk about that as P, because there's no sample being conducted. And we'd have 0.30 as my P or my parameter, okay? So this would be my proportion there, okay? Suppose that you randomly select 50 novels, so my little n being 50, okay? 50 from my entire population. These are the things that we have, and I would really literally write this out. This always helps me with what we're doing. Now, let's state the problem. The question B says, what is the probability? And a lot of times I like to just write this out. What is the probability? At least 20 of the 50, because that's the sample, right? 20 of the 50 novels have fewer than 40 pages, okay? All right, so this is the question we're trying to answer. And when we conclude it, we can then say, we can just restate the probability at least 20 of the 50 novels have less than, it's supposed to be 400, sorry, less than 400 pages. 20 of the 50 novels have less than 40 pages is, and then we'll list it there. So that would be my conclude. So I kind of start with the beginning and end, because they should mirror each other pretty closely there, okay? Now the plan stage, probably the hardest stage, is how do I execute this problem? That's the good question. Well, first off, we know that we're trying to take 20 of my total n, right? So we're trying to say 20 of 50. What is that proportion that's there? So we've got our P. Let's find our P hat, and we can find our P hat by saying 50 is my little n, 20 is the amount that I'm trying to find at least 20, right? So we would say that this right here would be 0.4, or I could reiterate this as, okay, we want my p hat, it's equal to 0.4, but if it's at least this amount, really we're trying to find, you don't have to put this, but what is the probability that x is going to be greater than or equal to 0.4, okay? That's going to be important for what we're going to come back to within this problem here, okay? And I'm going to actually erase this because I'm going to need some more space, so I don't need to reiterate that, but this would be good notation for what we're doing there, okay? All right, so the question becomes, what is the probability that at least 20 of these novels? Okay, so this right here is where we're at. If I see that it's at least 20 of the novels, and we see that it's a proportion, what's greater than or equal to 0.4, let's state a couple things. First off, we know that we're talking about p hat, and so we're going to see, can we use a normal distribution? So does n times p, is that greater than or equal to 10? And does n times 1 minus p, is that greater than or equal to 10? Well, as I look at it up on top here, okay, we would say 50 times my proportion, my p, would be 0.3. That would be 15, okay? And so that's greater than or equal to 10. So we've got that there. This bottom one would be 50 times 0.7, which would be 35. That does that is greater than 10. So because of that, and I guess the do stage would be kind of more down here, but because of that, we can assume that this distribution is approximately normal. But the problem is that in order to find this, we've got to find the mu of p hat when we do a sampling distribution and the standard deviation of p hat, okay? So we're trying to look for these two things. So this is the more of like the do phase. So the planning is setting us up for what we do down here. But before we execute it down here, let's first find what is the mu of p hat. Well, that's equal to p, which is also equal to 0.3. So we could rewrite this as n 0.3, comma, and my standard deviation of p hat. In order to show this, though, I can't just show it. I've got to, and I'll just put it down in this corner, but really this should, if I had room, come back to this. In order to use my formula, I've got to show my 10% condition, which states that little n is less than or equal to 1/10 of my big N. Well, big N is all novels in the library, okay? 1/10 of that surely will be greater than or equal to 50, okay? It's probably gonna be more than 500 novels in a library, especially, that's an assumption, but we're gonna assume that there. So since this 10% condition is in effect, we can use our formula, which is p times 1 minus p. So 0.3 times 1 minus 0.3, all over my standard deviation of 200. Oh, I'm sorry, all over my standard deviation, all over n, little n, my fault, all over 50, okay? So when I plug this in, I will end up getting a standard deviation of 0, so p hat, 0.0648, okay? All right, so we've got that there, so we'll just put 648, okay. All right, so we've got this here. We'll just put the 0.3 at this spot. The question is, though, remember the original statement, the planning stage, when we actually execute it, is if 0.3 is the mean, we're trying to see where x is greater than or equal to 0.4. So we're just going to say 0.4 is here. If it's greater than or equal to 0.4, we're trying to find the area that's here, okay? And I can find that by coming to my, I want to make sure I establish well, context will be more at the end, right? We got context at the end. So we just need to say normal CDF, because CDF. PDF we can't use, right? We can't use PDF. Cumulative is what we're looking for. So we'll say lower bound, upper bound, mean, standard deviation. Then I have to state normal CDF, lower bound, which is 0.4, upper bound, which is a high number, mean is 0.3, standard deviation is 0.0648, right? Okay. When I plug this in, my answer, when plugged in, right, form it. I've got it here. 0.0614. Okay. So what happens is this can then say the probability that at least 20 of the 50 novels have less than 400 pages. Sorry, is, and you could actually say 6.14%. You could also say or 0.0614. Okay. And we'll take either of those. But that's how you would do it. Again, you have your state, you have your plan, you have your doing, and then you finally have your conclusion. That's right here. Okay, I hope that was helpful for you in terms of sampling distributions that are there. The key here, I think, is executing this down here. What are we doing? What is our state? What's our plan? And executing it forward. You do that, I think, I feel pretty good of us finishing off that problem and going from there. I'll continue to go over some more problems that are similar to that, but wanted to at least give that to you and hope you have a fantastic day. See y'all.